Ladies and gentlemen, welcome to our fifth TEXNH event of the year. And a very warm welcome to both speaker, Dr. Athina Boleti, and our discussant, Dr. Nikos Papadimitriou. And a very warm welcome to everybody here and everybody online who is joining us. Our TEXNH event series started in January 23, and so far we have had 4 lectures already. We have had Helle Hoogscheid, who was talking on the effects of crafting in the forming of the Athenian polis. That was in January. That was a very interesting kickoff. That was followed in April by a very impressive talk by Daphne Williams, formerly from the British Museum, bringing together any form of cross-craft interaction between potters and pot painters in classical Athens in the Keramea area. Including aspects of training and how different age groups were linked to each other between the different types of crafts. Very fascinating talk. In May we had Erika Angliker, Associate Researcher of the British School, talking about cross-craft aspects related to religious contexts. So she was talking about the case study at the Sanctuary of École, where she was looking at aspects of music, but also aspects of dancing, the potential aspect of a dancing floor that they found there. Then we had a summer break, which is a good thing. And we started again in September with Dr. Despina Ignatiadou from the National Museum here in Athens, who has also worked for years in Thessaloniki. And she looked at the interesting cross-crafting aspects on different levels, so both materials but also technological processes of pyrotechnologies in the Hellenistic period. So she looked at aspects related to metalworking, pottery, and glass, with of course an emphasis on glass, which is her specialty. So today we're actually moving back in time and we go to the Bronze Age. So we've had classical and Hellenistic and Roman papers, because Despina also covered Roman times. So today we go back into the Aegean Bronze Age, which I'm particularly happy about. And our speaker of tonight is Dr. Athina Boleti, who graduated in 2002 from the University of Athens in Archaeology and History, and subsequently carried out her PhD research in the University 1 Sorbonne in Paris, on her thesis, which was published in 2017, on the exploitation and uses of the important mineral of embry, as an abrasive material in the Aegean and beyond. And this is also going to be touched on in her topic today. In the summer of 2020, and under very difficult conditions related to COVID, she started a 3-year Marie Curie-funded project at Leiden University, whereby she focused on studying mason's tools from several key sites in the Aegean in the 2nd millennium BCE. But she also focused a lot on carrying out experiments in that field. And perhaps we'll also hear about that today, which I'm very excited about. She's an associate researcher for the CNRS, and she has collaborated and participated in multiple projects in Greece, Albania, and France, considering lithic technology and crafts in the Aegean Bronze Age. I also want to introduce our discussants briefly, Dr. Nikos Papadimitriou, who is the director of the Paul and Alexandra Canellopoulos Museum in Plaka here. He has studied at both universities of Athens and Birmingham, and has worked at the Museum of Cycladic Arts, the Department of Antiquities in Cyprus, the Open University in Cyprus, and the Institute of Classical Archaeology of Heidelberg University in Germany. He is also a specialist in Aegean Bronze Age. Together with Eleni Konstantinidi and Akis Goumas, they work on research related to the use and making of gold objects, and they use very innovative research techniques there, including experiments, if I understand well. He has also collaborated with Athina Boleti in the recent past in a research program on the technology of early Cycladic marble working. So he's a perfect discussant for today, I'd say, and they're working on a publication together on that topic. So welcome both of you, welcome everybody. Athina, the floor is yours.
Thank you very much, Anne. For this introduction and for the invitation to this this very interesting series of conferences. So I'm talking about abrasive technologies today. We can define abrasives as materials, mainly mineral, of varying hardness, which can be used to process other materials by wearing and removing material from the surface to be processed. Nowadays, the term abrasive generally refers to a substance used for smoothing and polishing by rubbing. Abrasives have been widely used since the very beginnings of human subsistence and crafting activities to process a variety of materials: food, wood, bone, shell, stone. I will focus today on abrasive materials in form of powder, which can be used with specific tools, drills, but also with saws, and other viscous substances, as a means to explore technology and cross-craft interaction in the Bronze Age, in the Aegean world and its periphery. So drills are composite tools with a central axis, a piece of wood or reed, and their cutting edge can be solid, that is the wood itself, or a fixed drill bit made of stone or metal, or their cutting edge can be hollow, so the reed itself, or a fixed metal tube. The drill is put in rotation either by being twisted between the palms or by the use of different mechanisms, such as bows. The adjunction of an abrasive material in the form of natural sand or powder is in general necessary for cutting the material to process. So, it is the abrasive put in action by the drill that cuts the material to be processed. The principle of mechanical drilling was known already in the Eastern Mediterranean as early as the Neolithic and the early Bronze Age, that is the 7th to 3rd millennium BC. In regard with stoneworking, it was used for hollowing out vases in the 7th millennium BC in Western Anatolia, in the 4th millennium in Egypt and the Cyclades, and in the 3rd millennium in Crete. The tubular drill, more precisely, seems to have been first used on a large scale in stone vase production in pre-dynastic Egypt in the 4th millennium BC. Its use in other regions was limited at the same period to perforating stone maces, axes, hammers, and beads. In the Aegean, evidence for large-scale use of the tubular drill comes from Crete, where tubular drills were used along with drills with solid beads for hollowing out stone vases, as well for seal cutting and engraving from early Minoan 3 to late Minoan 3 BC, that is from 2200 BC and throughout the 2nd millennium BC. However, in Egypt, in the 3rd millennium, we have some first evidence for the use of drills in architecture in the early dynastic period. In King Djoser's funerary complex, mostly known for the step pyramid, the first pyramid to be built in stone, several drill marks with the solid chert beads are mentioned, like the ones seen on the capitals of the fluted columns at the Hebset court, but also on the boundary stelae reused in revetments, some blocks at Mastaba M2. Thus, beside the forms like those applied in columns, which recall forms already seen in stone vases, techniques mastered in stone vase production were here applied and tested on a bigger scale in masonry in the first monuments erected entirely in stone. It is generally admitted thus that vase makers have applied themselves here in architecture. We only find scarce evidence of this type of marks in the monuments of the following periods. But as I have argued elsewhere, it seems that in Crete we have evidence for the same phenomenon during the Palatial period. At the site of Agia Triada in southern Crete, a limestone quadrangular block bears traces of drilling with a tubular drill on 4 sides. There are at least 3 fragmented bore cores which remained undetached. The block was found in late Minoan 382 foundations, so in the 14th, dating the 14th century BC, the period of Mycenaean presence on the island, in the northeastern area of the site, but can be of an earlier date. Drilling has been used here very probably to shape the block. Some puzzling tool marks on some architectural elements at the Palace of Festos could also be drilling marks, like the ones on the block from Festos, but partially erased with the use of percussive tools like chisels. This is the case of the block reused in corridor A. Here, we can see it here, but also eventually of the porous limestone orthostates of the first palace. If this is the case, here again, A well-mastered technique developed for stone vase production was tested and applied on a large scale in masonry. The advantage of this technique would be that large and solid volumes could be cut with the minimum risk of breakage and with the highest possible precision compared with the use of percussive tools like picks, axes, chisels. In general, the drill, tubular or solid, is a tool entirely mastered by craftsmen and widely used both in Egypt and on Crete in the Bronze Age. On Crete, it is even used on hard limestone at the Palace of Malia, already in the Proto-Palatial period, after Joseph Shaw to excavate mortices for wooden dolls. Given their wide use in other crafts and on different scales, the fact that in Egypt, a drill with a copper end piece became the hieroglyph for a stone vessel producer and later for a craftsman surely echoes their generalized use and essential role in crafts. Perhaps we can say the same for saws, a tool well mastered and used in different crafts also. As in the linear bitex from the Mycenaean world, we find a term apart for the sawyer, thus a term indicating the action, the operation, and not the craft. Quite different use for the drills has also been considered recently. A series of enigmatic blocks of limestone bearing multiple drill cuts are known in Egypt from sites dating mainly to the 6th dynasty, so to the Old Kingdom. These are not related to any architectural elements or stone objects production, and it has been suggested that the goal of this drilling process was exclusively to obtain limestone powder in a quicker and more efficient way than grinding with the stone, which would further require sieving to obtain the same fine-grained powder. The need for obtaining in a short time important quantities of limestone powder was associated to the needs for plastering and whitewashing the tombs for ritual and cultic reasons during this period. I don't know if this can be valid for plaster production in general, but in Egypt and or in the Aegean world. But the idea of producing powder with a drill is interesting, showing how important, how useful can this tool be. It is also reasonable to assume that the byproducts of stone vase drilling, that is the finely ground and powdered abrasive, was further used for drilling on a smaller scale, namely for stone seals and beads, especially for the perforations. Once again, this process is quicker than grounding the abrasives to a finer granulometry and does not require sieving to obtain grains of the same size. This could also explain some patterns of use of emery in Minoan contexts. Emery is an abrasive material par excellence. It contains corundum, a crystallized form of aluminium oxide, which is 9 on the Mohs scale of hardness, just before diamond, which is 10. Occurrences of emery in the Eastern Mediterranean are known on the island of Naxos in Greece and the Menderes Massif in Turkey. Its use already in the 4th and 3rd millenniums BC in Egypt for the production of stone vases is still strongly debated. Literary evidence attests to its use in the 2nd millennium. More precisely, the annals of Amenemhat II, inscribed in the Temple of Ptah in Memphis during his reign, that is in the beginning of the 19th century BC, make clear reference to emery imports. More precisely, the annals mention an expedition in Lebanon or in Syria, aiming at acquiring supplies in metals and minerals, including considerable quantities of emery powder. 226 kilos after Altenmüller and Musa, or 453 kilos after Grimal, depending on the publication. The same annals mention 83 emery blocks delivered to the pharaonic administration for distribution. It is only very recently that corundum was identified in the drilling cuts on a limestone block from the Amarna period, dating to the 14th century BC. And this is also very interesting because this block actually came from the 1891 excavations at the site by Petrie and Carter. It was then, it entered then the collection of the Metropolitan Museum, and it was only in early in 2014 that analysis was conducted, demonstrating the use of emery of corundum in Egypt. On the contrary, it is generally accepted that emery revolutionized hardstone industries in the 2nd millennium BC in Mesopotamia and the Eastern Mediterranean, this time on the basis of archaeological finds. In the Aegean, emery is found mainly on Crete in form of percussive and abrasive tools, but also in form of powder used with drills. It has been identified by analysis of the residues on bore cores. So we have some 4 more precisely from Knossos on banded tufa, Bratsia, serpentinite, and gabbro. Only one of an Egyptian alabaster and one from jasper siltstone. What may be surprising is that emery is not used exclusively on hard stones, as it would be expected for an imported and thus valuable material. Experiments have shown that grounding pure corundum was relatively easy, but grounding emery, what is mostly found, more easily found in the sources, demanded more energy and time investment, and eventually even thermic treatment, that is heating and then cooling the rock to weaken it before grounding. Elise Moreau, who conducted drilling experiments with corundum as an abrasive, observed that emery did not accelerate the drilling process of soft stones or of stones of medium hardness like marble, but the quantity of abrasive required was smaller compared with drilling with quartz as an abrasive. In other words, they were not wasting their abrasive using it this way, but grounding it finer for use with smaller drills. Going back to the discussion of the byproducts of drilling, another possible use is that of the production of vitreous material, like faience and glass. Dennis Stock's experiments showed that the powders derived from drilling hard limestone and calcite are ideal for making faience cores, and that the powders derived from hard stones drilling, containing thus more copper particles, are suitable for blue glazes. So he claimed that already in the 4th millennium BC, Egyptian craftsmen did not need to produce powders especially for faience or for blue fluid and pigment, because the powders required were already available as byproduct from the drilling of stone with copper tubes and sand abrasives. So silica would be in the form of quartz used as an abrasive, lime from the limestone that was drilled, and copper oxides would be coming from the user of the metal drill. Stokes even assumed that the expansion of stone vessel making in the Lakkada II period may have stimulated a commensurate increase in faience production. This assumption seems to be confirmed, at least partially, for the late Bronze Age. Some beads dating to the Second Intermediate period, so 18th, 16th century BC, from the site of Esna in Egypt, were analyzed and found to contain tin oxide, indicating indeed the use of scrap metal in form of copper tin alloys. So this could be waste from the production of bronze objects, from polishing or sharpening operations, or waste from the use of bronze tools like drills. Percentages of copper and tin in faience products of the late Bronze Age, so that is indeed when copper tin alloys are used more widely, or even used as a means to confirm or enrich data on the exact types of copper alloys for this period in Egypt. More analyses are definitely required to extrapolate more concrete results, especially for the Aegean world, where an important local production of faience existed in the 2nd millennium, reaching its peak on Crete during the Neo-Palatial period. The use of scrap bronze is also assumed for the production of frit and glass. The principal components for these industries are in general the same as for faience, but higher temperatures allow for the melting of the preparation. In the previous NIA conference on glass production of the historical periods, among others, Despina Ignatiadou mentioned the use of corundum, a fine powder of corundum with the clay molds used for glass production at the workshop of Phidias at Olympia. Corundum is an aluminium oxide and would be used in this case as a thermal absorbent. I was then interested in the possibility of the use of corundum in Bronze Age glass making, which can be considered, I think, some cross-conference interaction. Glass is one of the most important and productive Mycenaean industries, with a peak period in the late Helladic 3A and 3B period, so that is 14th, 12th century BC, so the period of the Mycenaean palaces. In their analysis of glass from different Mycenaean sites, Zacharias and his team put in evidence a group of glass plaques from Mycenae, which differs significantly from the other groups analyzed due to very high percentage of alumina, that is above 7%, while high percentages of silica indicated a pure silica source like quartz pebbles. This unique group attests to different technological choices and thus a distinct technology, eventually specific to the workshops of Mycenae. Could this excess of alumina be related to the use of byproducts of abrasion involving corundum? Or could this have been used here as well with the molds used for the production of the plaques? This is a field to further explore eventually. In all cases, during this period, the period of Mycenaean palaces on Crete and on Greek mainland, emery is largely distributed and shows a generalized use. Strong Mycenaean presence on Naxos, as suggested by the flourishing settlement of Grota, a small-scale follow tomb in the northeastern part of the island, and other finds in the region of the emery sources could be especially related to the exploitation of the emery sources on the island. That is the largest source existing on the Aegean Islands. So, besides stoneworking, emery tools come from contexts relating to metalworking, like at the unexplored mansion at Knossos, while some rather unusual uses, most possibly in form and powder, are also recorded. More precisely, emery has been reported as a filling substance for Mycenaean gold rings and gold relief beads. The properties of emery for which it would have been chosen, possibly as a recycled material in these last cases, are not yet evident to us. Byproducts issued from abrasive operations in the framework of metalworking, like removing flash left after casting, further shaping, sharpening, polishing bronze objects with stone rubbers or whetstones, can also be recycled in other crafts. Here again, a representation from the Old Kingdom in Egypt. It is interpreted as a preparation for a sandstone abrasive to be used for polishing or sanding in carpentry. The instrument illustrated, the tool illustrated, grinding the sandstone block, is interpreted as an adze, and we can see indeed the sand particles falling off. This operation is not very different from sharpening metal tools, as we can see here from some sharpening experiments. These byproducts of abrasion in stone and metal crafts could provide craftsmen with a wide range of polishing powders and putties in terms of composition, limestone, sandstone, emery, pumice grains, and metal particles, and grain size, which would allow them to apply successive polishing sequences and obtain very high polishes on different materials. Fine analysis of polishes on stone, metal, and other materials is required to highlight this operation, delicate to reconstitute, especially for metal objects whose surfaces are largely eroded. And I'm thinking, for instance, Mycenaean bronze mirrors, which would require a high polish. Abrasives considered here and related mechanisms allow us to make the connection between different crafts, from stone vase production to stone architecture, from stone crafts to crafts involving pyrotechnology and vitreous materials, and others very briefly considered here. This cross-craft interaction then reveals or hints to a strong material engagement. Craftsmen have deep knowledge of the properties of a variety of materials, if not of the majority of known materials, of an economy of materials in the sense that they economize their materials. The residue materials are recycled, they are not wasted. They also hint to multi-crafting in certain cases. The same craftsman may be able to perform the same crafts on different scale or different crafts, like stoneworking and metallurgy. And finally, a proximity of craftsmen and their working areas, or workshops when we can identify them, where they can share materials, equipment, and installations. Thank you. That's rather dense.
Because I could see that there were still some slides coming, but maybe this is not part of the presentation.
No, that's extra material.
Thank you very much, Athina, for a very interesting discussion on the different materials that are actually all linked by something as simple as powders and drilling, which are technologies that are often overlooked when we look at a variety of different specific technologies like metalworking or stoneworking or this or that. So it's very interesting to see how they bring it together. I think I would like to give the word to Nikos, who will lead the rest of the discussion. We need the microphone to be passed on between people, if that's possible.
Okay. So thank you very much, Anne. First of all, for the very kind invitation. It's extremely interesting event and series. Thanks to Athina for this very interesting presentation that we have a chance to discuss in other occasions. I will make some comments. I think first of all it is important to see, as Anne said, all these kind of materials that we may have easily mixed as simple stones if we haven't seen some experiments. So it is very possible that any of the tools have been misinterpreted as stones in the past, unless you have the specimens who can recognize this. And surely very few people would collect abrasive powder in place. I mean, sometimes it happens, but I can recall now all this fantastic context in the Athena École, where they have collected since the 50s, but other people they have misinterpreted. So it is important to see a lot of not only logical presentations, but experimental presentations in order to understand how this thing may look like when we dig. I think that one of a lot of questions, of course, come out of your presentation, but I think that the main thing for me is the question of language. Now, in English, we use the word craft, which sounds very well defined, and like enclosed entities, and especially when we say cross-craft, the cross is a very powerful word. It looks like we have something which is very clear, and then two things come, they are opposite, and they suddenly meet. While in French, there is a much more fluid language, and you have the polyvalence as a humanity uses so often, which gives this idea of versatility. And I think that this relates more closely to what's happening really, what you saw is here, which is so interesting. and such an interesting parallel to have the Egyptian and the Minoan cases. It brings to mind that, we see three workshops here. The Egyptians may see one workshop. It's for us that we see three workshops, the same not for Maya. Because at least two of them, they have to do with fire. And clay and metal, they very easily work together. And for me, my experience working with Assyrian weapons and things like that, people who work in these workshops, they need to collaborate continuously with people working with precious metals or wood or things like that. And like can tell us more than anything how wood and bronze should be put together. So I think that all these distinctions we have, they don't correspond to reality. So this is a very useful presentation. And now you introduce also the idea of this recycling and what people do with residues, which is really, really thought-provoking. I have two questions here. First of all, what you discuss is a kind of exchange of materials among different groups of craftsmen, let's say, and recycling of material in a sense. In the case that nothing gets lost, which also means an exchange of knowledge, an exchange of information in a way. And I was thinking that, okay, most of them are quite commonplace technologies, what we see here, but we're in the second millennium. And in the second millennium, we live in societies of palaces and empires and things like that. And you showed the Athena temple, and I thought that the Magna tablet you have all this discussion of kings exchanging materials and technologies and specialists and things like that. So I wondered, okay, we often use these collaborative altruistic models for craftsmen exchanging knowledge among themselves openly. We know that this is very often quite the contrary, that craftsmen can be very close and very competitive. So my question is, do you have any information about this? Do you have any information about the control of the materials and control of the information in this kind of context? Can it circulate so freely? My impression is that it circulates freely, but I'm asking if we do have something to say there. And the second thing I was thinking is, we speak about the craftsmen and workshops and things like that as if they are based on a place. But quite often they may move around. I remember now the work done by Moritz, Kinderler, Nanoheim, and this group of people, Momsen, for the tribal councils, the early Iron Age. And they, one may agree or disagree with them, but they made a very strong case for traveling groups of bronzesmiths who carried on their own material or otherwise, but they raised this discussion. So we may have mobile craftsmen, which is normal for the early Iron Age, with sanctuaries and all these kind of things, and I suppose also in the Bronze Age we may have similar periodic things. And I wonder whether you can, or you would like also to comment on how this cross-craft idea would work in a more mobile world of craftsmanship. I stop here because I asked a lot.
I agree on all. Indeed, there is this proximity, I think. Knowledge is accessible. So if there is specialization, let's say, specialization does not exclude polyvalence, multitasking, multi-crafting. That is, a craftsman can have different skills and knowledge, so he can know how to work stone and bronze, but then it's a matter of other parameters how he will work actually, if he will be registered in, for example, in the Egyptian archives or Mycenaean, etc., as a specialist of something, depending on the patterns of production, the demand, so the organization of the production actually, what do they want? It's not that they cannot, I don't believe they have reached a stage where this knowledge and skill is so isolated. They know what's is happening on the other crafts and the other materials, but then it's a sort of organization of production that they may actually work on something more specific. So this is one thing, but I believe it is just like the images we have here from Egypt or from Crete. So with this proximity of working areas, they see what's happening when working on different materials. To answer to the second question about mobility, so first they have access to this knowledge, to this data, and we know they're also this does not exclude that they move, they circulate. So we have the evidence for the exchanges between the kings in the Eastern Mediterranean. So they can go and see elsewhere how they are working. And this can be on different scales. Local scale in the Aegean world, larger scale in the Eastern Mediterranean. I don't think there is this notion of secrets of in the framework of a craft for this period. In this period, but for later periods as well. I think, for example, for Middle Ages, regarding stonemasons and engineers of construction, etc. I don't remember if it was 11th or 12th centuries. They are sending them elsewhere to see how they are. So the commoditors who are asking for the construction project, they are sending them elsewhere to see how they are doing, what they're doing, what new they're doing, so that they can come and reproduce it. So that's quite. I don't know if it's.
Do you have any comments on your remarks made so far? In relation to exactly these topics, I was also wondering exactly how the transfer of knowledge and the transfer of materials that we can see in the archaeological records are to a point, but the transfer of knowledge happens on the ground. I mean, it's clear that we're looking here at transfer of knowledge on the level of, let's say, elite structures, elite social groups, and perhaps less on other levels. Would you say, because abrasive technologies are not just used in elite context, would you say that there is transfer of knowledge on other levels as well? I mean, I'm sort of thinking also in relation to the objects that we find and the lack of knowledge or the lack of information we have at the moment to see it happening over the entire spectrum. And part of it is that we haven't actually looked for it, number one. Secondly, the analyses have not been performed, even if they were resolved. Thirdly, objects have been washed, consolidated sometimes with plastic materials such as polymers, so the residue may not be visible anymore, and so on and so on. So I'm just wondering how far that on the ground level of an Egyptian person or even a person from Crete going to an island or somewhere on the mainland with a specific knowledge, in how far can we trace that in the archaeological material, do you think, if we look more carefully in the future to this context of abrasive materials and related crafts that produce materials?
Yes, I think that the methodological approach should be oriented more to analysis, of course. I found very interesting the example from the residues, the corundum residues in Egypt, that were finally identified a century after they were excavated, came to the light. I think this is definitely a direction to follow.
Is it possible
for the online?
Is it possible to have to find a limit, an upper limit for the distribution of knowledge or even for the discovery of memory in hydrogen?
Is it possible?
Not on the limit on the memory. Because you did you find traces in Paras, in Mycenaean, because you said that there were evidence in the Mycenaean Paras concrete, and you provide.
Yes, there is not much evidence for mainland Greece, Mycenaean Greece. There is just the Petri, when he was at Athens, says that he found some pieces, some of emery, which were related to some rotted bronze. So he supposed they were saws with emery bits as forming the cutting edge. But this is Petri, and there is a century. And apart from that, there this peculiar presence of emery in related to gold rings and the beads, the gold leaf beads. It's with gold, with jewelry, it's emery powder, apparently, if I understand well, which forms the core of a gold ring. This is what Inger mentions, and with beads of gold leaf. Again, if I understand well, as a core, and there is no for the moment no other sign of. So it's a matter of yes. Now in another context, that would be early Bronze Age in Troy, as you mentioned. There are researchers studying beads, and they claim that emery has been used for the drilling, and this time on the basis of usual traces. So there are a few elements here and there dispersed. There is a need for something more systematic and to have a corpus that is really substantial.
We have one question from Zoom, if I may. Hannah Hochschild says, thank you very much, Athina. That was fascinating. My question is, they can hear me from here. My question is, could the presence of emery on Naxos with marble also available in Crete have to do with the early development of sculpture there? In other words, could the presence of abrasive play a role in the emergence of the craft of sculpture to a similar degree as the presence of the material for the sculptures even?
Yes, this is what Casson has suggested already in 1930, I think. And so this is exactly what he's saying, that they used the archaic sculpture, but also Cycladic figurines. The development of these crafts are thanks to the presence of marble and emery on Naxos. And so he explains how they could, with the abrasion, they could work stone carefully without any risk of breaking easily, etc. So it is reasonable. And then there is so the archaeological evidence for this.
I was also intrigued by the recognition of the material in glass and finance production, both in the Mycenaean periods, in the paper of Zacharias and his collaborators, and also by the work by Papadimitriou. Why do people choose, because you were mentioning that it would be a deliberate choice perhaps in certain cases, why do people deliberately choose for this material and not another material? Does it have any visual different properties or any other properties that would enhance the production of that group of material, or what is your idea on that?
Yeah, well, first this needs a confirmation, this interpretation. I just found it so interesting, and I wanted to mention that. And that's what I'm also wondering, if there is a special reason for, if there's such a, if they add corundum in the end, like for instance, for the molds at Olympia, it's mentioned, was a thermal, forgot the word. So it was used for to regulate temperature, or was it just once again, let's say, recycling of a considerable quantity of residues containing corundum? But it's only one case, so there should be more to see if it is indeed a different technique and a specific technological choice.
Okay.
But I find this interesting, so in all cases.
Well, I want to ask you something about the if they use emery powder for the elaboration of wood. If we have some hints of pieces of information, even from the later periods, historical one, like emery powder glued on some piece of leather and then uses as a paper glass to elaborate the wooden surface. Do you have something in mind?
In general, emery is related to hard stone working.
Okay.
That's why I mentioned the case of using emery to drill softer stones like serpentinite. Why are they using emery for something they can do with something else, with quartz? Yes. So
We don't have
I have no reference about that, but perhaps we cannot exclude it. The basis of there is an abundance of material, like in later periods, and it is easily accessible, and then you can use emery paper for everything. But it can be used exactly for polishing on a material like, as you said, skin or something like that, or tissue or textile for the polishing, top light.
we will be experimenting
Yes.
together.
Great.
Athina, Nikos from the Turkish. I just had a question about the extraction, because we have the material, and the question is if we have any evidence, we know that naturally is a nature extraction, certainly in recent times. I remember the years of Papadimitriou, the years have suggested that the Bronze Age extracted, they used pieces that had flaked off, let's say, or, and also he says that they are found in the same areas with marble pieces. Do we have any evidence if the core is somehow emery, and if they do have an idea of how this could be done, since it is so hard? As you said, it's the hardest thing after
Diamond, corundum, yes. This is a a problem. So there may be some superficial alluvial occurrences, indeed. There are also some occurrences that are not very deep at Naxos. For instance, when I was there for my PhD, they were just doing some extraction for foundations for houses, and there they were finding emery. It was a special type of emery because there are different types depending on the degree of metamorphism. So it was emery-rich emery, which is not very dense and compact. So you can. So this is one possibility. If they were, from time to time, they found some occurrences like this. Otherwise, there are no signs of, no evidence for extraction, which could be indeed complicated. But recently, there is actually the publication of the Çukuritsi Huyuk site in Turkey. So it's a site of an early period, Chalcolithic, and where they have the first elements of metallurgy. So there are occurrences in Turkey as well, in this region. And there they have found some mining, yes. So, of course, in Turkey there are many more alluvial deposits than in Greece. So this is interesting also to see if there is some more evidence, more details there, to see if we can say something about the techniques. But it's already in the Chalcolithic early Bronze Age. And in regard with metallurgy, because they're using emery for the anvils and the hammers, for crushing and for working metal ores and working metal. So here again, for this field, there's also perhaps research that can tell us more.
Since we're talking about the production chain, the extraction, I have a question related to the activity of using the abrasive material in combination with either a saw or drill at the moment where the action is performed, which I would imagine will create a certain level of heat. I'm not entirely sure, but that's what I would like to ask you. In order to regulate a bit, if that would be necessary, would the material have a carrier? Would it be a carrier like water or any other liquid or form of protein material of organic origin that could also be analyzed in specific cases where you would expect something like that to come and the object has not been cleaned out too far?
There are substances, water or other used with. It's a matter of rheology. Otherwise, the abrasive will not circulate. Indeed, it's a very important parameter for the functioning of the drill. I don't know about that. Elise Morero, if she, I don't remember if she, I know there were some materials like wax used for polishing. I don't know, I think she tested that as well with her drilling experiments.
Because what you will not analyze or find, of course, but any other possibly kind of material may be found sometimes.
Yes, like wax, for instance, or something like that.
Actually, I was wondering, did you remember from your experiments, it also produced smells and sensory comments, let's say, and if so, do you think that the craftsman would take into account these senses and in order to regulate the way it uses the abrasive material?
Yes, definitely, because I think Elisa, she is talking about this in detail, the sound changes depending on the grain condition. In the beginning, it is more intense, and then as it is ground down, it flows easier and quicker, and so it is different. And I think that's how they also understood that perhaps they have to add abrasives, or if there was a problem, or water, lubricant, whatever. The sound was definitely telling them how it was functioning.
And actually, just to add something having worked your experience with the issue of the experiment done with the silkstones, it is extremely important, the sound, because you don't see much. Because there is so much of this paste that Papadimitriou is getting out of the water, also, you don't see it. So you have to hear how these things work, and then you stop, you touch it, you clean it a bit, you may take a cast. I remember when Nikos was doing the example with the case treatment, seems like a cast to see the result. So it was, very much, we were doing the same thing with hard stone and Leiden, don't say it's an awful sound. You hear the awful scratch of this kind of thing.
Exactly, yes. Can be.
I was wondering what kind of scientific technique do you use when you do like microanalysis, especially when you work with powder and abrasive, with soaps and materials? What kind of technologies do you apply?
It depends. We were using thin sections, so the microscope, and XRD, XRF for this, just to see if the composition.
I have a question related to the slide you showed with the plaster drillings, multiple drillings in one specific stone with the limestone. Yes, exactly. We've already discussed it, but I think it's useful to go over it again here. If this very fine material is drilled out of limestone, you mentioned that it could be used for a variety of uses, including plastering, pigments, and so on. I agree with the pigments, because then you have a very fine material, and you can mix it with an organic binder, whether that's water or anything else, and paint it on any surface like mud plaster, lime plaster, gypsum plaster, on a dry surface. However, if you want to use that material as a plaster material itself, it's not going to work. But simply using that the limestone as you have it, whether it's as a stone or just a grain of it, has not gone through the lime cycle. And that basically means you need to, it's quite a technology of lime blaster, basically. You need to burn your limestone by 800-900 degrees Celsius. After which half of its weight, more or less, I think about 43%, disappears in the air. Then you have quicklime, which is a very reactive material. The quicklime blocks in the furnace or oven need to be pounded down and grind down. And water is added to it, and you have calcium hydroxide, which is an exothermic. It causes a lot of heat and it's an exothermic reaction. And then you have some kind of a putty, and it could be very thick one or very thin one. So the thick one will be for plastering, the thin one will be for whitewashing, or facade, or mud brick, or any type of facade. Let's say very thin layer. If you do plastering, it could be 1 centimeter, half centimeter, whatever. At that point, with a lime plaster specifically, when it's still vaguely wet, you can paint on it with your pigments suspended in water in a fresco technique. It's the drying up of the lime plaster that will lock in by the crystallization of that plaster the pigments inside. If you want to remove the pigment layer, you have to literally scrape it off the wall. If it's done on a dry surface, gypsum plaster or dry limestone, you need that mixed organic material with it in order to stick it on the wall, and only with water or alcohol or any other material will be able to remove it. So I would say that this material, this fine-grained material produced by a drill, they have described it, can be used for pigments. It can be used as a filler in plaster, but not as plaster material itself. It can be used as a way to make something white by mixing it with water. And it will be temporarily stay on that surface, but once it's dry, you can rub it up with your finger, you can even blow it up. It has no binding properties. So I think the Polish person who has written this paper should see it also in the context of plastering as part of the life cycle technology, not just in this way.
Yes, indeed. It's an isolated case. My other interpretations were tests, practicing, craftsmen that were practicing with their drill, or drilling, being these blocks being the support for something else which is on them, which is being drilled. So drilling goes continuous, and so they are also drilled. So the idea of this way of producing, or more precisely of using the tool, was interesting for me. That was this scale, and yeah. After that, for the application, indeed, plaster. I don't know if it's something really special to this, specific to this case. What he's mentioning, like a ritual, whether it could be something quickly and easily made, and they didn't really bother if it was not really plaster, just a ritual cleaning of the area.
And that's very possible with the material. And as you also mentioned, this material doesn't need any sieving, and that will take a lot of time away from getting the final material you want. With this, you have the fine powder you need it immediately without doing sieving or purification. That makes a lot of sense.
Yeah, just it was a mechanism. That was interesting.
Any other questions, comments, remarks? In that case, I would like to thank both Athina and Nikos for setting out wonderful topic to discuss and a good discussion. And I would like to invite everybody who's here at least for a drink upstairs to continue maybe talking about this subject. Thank you very much.
Thank you very much. Thank you.